I hope you are well today. Our goals for today are to do application problems for exponential growth and decay, and then also compound interest problems. So there are two different formulas, one for growth and one for decay, and they are very, very similar. The only difference is that growth problems have a plus sign in their formula, and decay problems have a minus sign. That is because the exponential growth problems are supposed to be increasing over time. So you'll see words like increase or appreciate or grow. Decay problems have the minus sign because they are decaying or decreasing over time. So you will hear those words like decay, depreciate, or go down. Those are the types of words that would say use the decay formula. In both of these formulas, you're going to notice a bunch of different things. This y is your ending amount. It's the final amount. The a is your initial amount. So it's however many you're starting with at the beginning. 1 is representing 100%, and then you're either adding your growth rate or subtracting your growth rate. And then your exponent here is your time in both of this. So they're both to the t. For your growth rate, that R value, there is something special about that. That is the rate of change. It has to be expressed as a decimal. So for instance, if you had a 25% growth as a decimal, that would be 0.25. If you need a little bit of help with that, wherever your decimal point is over, or is as a percent, you're going to move it over 2 decimal places to convert it into that decimal. So for instance, if you had 3.2%, you would take and you would move the decimal point over 2 spots, and this would be 0.032. So let's go ahead and take a look at some examples using these formulas. So the number 1 states Mrs. Smith received a job as a teacher with a starting salary of $39,000. So right there, once you see the word starting salary, this here is your initial amount. So therefore, it is your A value. In her contract, she gets a 1.5% increase every year. So this 1.5%, that is going to be your R value, but we are going to move that decimal over 2 spots, so it's going to be 0.015. We are looking for how much she's going to earn in 7 years. So your 7 years is your time. How much she's going to earn is her ending amount. So we don't know the ending amount. So this one, she is increasing her salary. So what we're going to do is we're going to plug this in for the exponential growth formula. So it's going to be y equals our starting amount, which is 39,000, times 1 plus our growth, so 0.015% rate of change, to the time. So that's to the 7th power. So now what I'm going to do is I'm going to scroll up a little bit so we can see this a little bit better. So we have our equation, and I did want to show you how to enter this in on your calculators just to make sure we're all on the same page with that as well. So in your calculator, what you're going to do is you're just going to type it all in at the same time. So 39,000 times 1 plus your growth, which is 0.015 for this one. And then anytime you have to do the exponent, it's going to be that caret key that's highlighted in red right now. And it's to the 7th power, and we're going to hit enter. And that is going to be our answer. We're going to round to 2 decimal places, the nearest hundredths, unless it doesn't make sense to do that in the problem. So our answer for this one is $43,283.95. Let's take a look at the next one. We have a population that is decreasing. So when you see this decreasing right here, you can think decay. So the rate is 0.03%. That is going to be your R value, but we do want to move it over 2 spots because it is a percent and we need to change it to a decimal. So it's 0.003. In 2000, its population was 88,647. That is going to be our initial amount, our A value. So the first part is asking us to write an equation. So our equation is going to have y because we don't know the ending amount. We do know the starting amount as 88,647. We know it's 1 minus, because it's a decreasing problem, a decay problem, 0.003 to the time. We don't know our time, so we're leaving it alone as a t right now. So this is our equation that we can then plug in any different number of things based off of what we're given in the problem. So for part B, it says if the trend continues, predict the population in 2020. So what's happening there is we are being given our time. Now you have to be careful because time does not equal 2020. Time for this one started in 2000. So in the year 2020, what we have to do is we have to figure out how many years have passed. So we can really do 2020 minus our starting amount. Or if you were able to look at this and say, hey, it's 20 years, that's great. Okay, because that's what we're going to use for our t. So 20 is going to be our exponent. We type all of this in on our calculator. We get 834,000, nope, 83,000. There we go. That makes more sense. 83,477.07. Now for this one, it doesn't make sense to have 0.07 because we're talking about people. So what we're going to do is we're going to just round to the nearest person on this. So 83,477 people. So that's an example of exponential growth followed by an example of exponential decay. There's also one other thing that exponential functions help us with these applications right now. It's compound interest. This is actually remarkably similar to your growth formula, but there's this new part, an n. This is your new portion here. The rest of the stuff is actually quite similar. So for instance, your A is your ending amount. That part's the same. It's your ending amount. P is your principal. That's another way of saying your initial. R is your rate. That is still going to be written as a decimal. T is still going to be your time. That part's all the same. Again, the new part here is the N. In these problems, you're going to have something said like your interest is compounded annually, daily, weekly. It's going to have the word compounded in it, and then it's going to have another word followed by that. And that word, whatever follows the word compounded, is going to tell you what number to use for n. N is supposed to be how many times something is compounded per year. So if something is compounded annually, that means that is going to be once per year. So n in this formula would be 1. You'd plug it into both of those places for n. Semi-annually would be twice per year. Quarterly, there are 4 quarters to the year. So if it says compounded quarterly, you're going to plug in 4 for your n values. Monthly would be 12 times per year. Weekly, we're just going to use 52 weeks in a year. And daily, we're going to use 365 days in a year. Okay, so now I know some of those don't, like 52 and 1/7 or 365 and 1/4 would be more exact, but we're just going to use these values. So let's go ahead and see what this looks like in a problem. So Maria's parents invested $14,000. This is your principal or your initial amount. It is 6% is your R value, but again, it's going to move your decimal over to get 0.06. And here's the keywords here, compounded monthly. So for this problem, N is going to equal 12. We're looking for how much money we would have in the account after 10 years. Our time for this one is going to be 10. So our ending amount is going to equal the principal times 1 plus your rate, which is 0.06, divided by n, and in this case n is 12, all being raised to the n times c. So that's what your setup is going to look like for this one. I also wanted to show you how to type this one in on your calculator just because it's slightly different. You are going to go ahead and just type in everything as it is. So we're going to do 14,000 times 1 plus, and we're going to do 0.06 divided by, oops, the 0 didn't make its way in there. Let's try that again. 0.06 divided by 12, because that's r over n. And we're going to close our parentheses, and we're going to write to the. Now, depending on your calculator, some of your calculators won't bump up and have that like blanking box up there. So I would strongly recommend using parentheses here and doing your 12 times 10 in parentheses. And so when we do that, we see our final answer being 25,471 and oops, and 50, was it 55 cents? I think so. Yep, 55 cents. Okay, let's try one more. So we have another deposit, and reading through it, we have our interest rate. Again, we know this is our new formula, the compound interest, because it says compounded daily. So he's not adding or withdrawing anything. So we're going to write our equation. It's going to be y equals our initial amount times 1 plus r. Remember our r, we have to move our decimal over. So it's 0.032 divided by n. Since this is daily, that means n equals 365 to the n times. Now we don't know t because this one is just asking us to write an equation so we can plug anything in. So this is our equation. It has an input and an output. We're going to use that equation to answer part B. Now we are given our t value. So we're going to go ahead and plug in 6 for t. We're going to type that all in our calculator and we're going to hit enter and we're going to get $1,453.99. Thank you for listening. I hope this helped.